Hello everyone, welcome to the presentation of our project for EEE 304 Digital Electronics Laboratory. The title of our project is Real-Time Density-Based Traffic Light Controller using Verilog and Microcontroller.
The Intelligent Traffic Light Control System is designed to be employed in a four-way junction. The system heavily depends on sensors. As we can see, each road has three sensors to detect vehicles on them, which would indicate traffic pressure on that particular road. Sensors A1, A2 and A3 are there to detect vehicle density on road A, while similarly we have sensors B1, B2, B3 for road B, C1, C2, C3 for road C, and D1, D2, D3 for road D. We are expressing these 12 sensors as density tracking sensors. From these 12 sensors, it can be determined how many vehicles are on each road and which road needs to be able to have moving vehicles before the other roads. For example, if A1 is the only one detecting while A2 and A3 do not detect anything on road A, that means the vehicle pressure is not that high on this road. But if all these are detecting vehicles, then the traffic pressure is high on road A. Along with this, there are also four sound sensors SS1, SS2, SS3 and SS4 on four roads to detect the presence of any emergency vehicle. In an event of any emergency vehicle being present in any of the four roads, their particular sound sensor will detect the sound of siren or whatever emergency audible indicator they are using and pass that information along to prioritize that road over the others. For example, if the sound sensor on road C detects an emergency vehicle, then this will pass that information along to prioritize this road over the other ones. Also, there are four sensors RC1, RC2, RC3 and RC4 to detect vehicles which are violating traffic rules. When any of these sensors are activated, they will trigger a camera module which will eventually capture pictures of the corresponding vehicle which is violating traffic rule by crossing permissible stopping line. So now I'll be talking about the algorithms and logics behind our traffic controller system. Here you can see our state diagram. Our traffic controller system has a total of 27 states. The system starts or resets from the S0 state or state 0. After that, it checks the outputs of density tracking sensors and sound sensors. If there is any emergency vehicle present on the junction, then sound sensor is activated and we move directly to S22. Otherwise, the density tracking sensors are activated and we move to state 1. In state S1, we search for the road that has the greatest vehicle density. There is a max output function in our code that does this job. Our system moves to S2, S3, S4 or S5 if there are greater vehicle density on road A, B, C or D respectively. For example, if road A has more traffic, then our system will move to S2 directly from S1. From state S2, the system can move to three different states S6, S7 or S8 depending on the output of density tracking sensors. If there is a huge amount of traffic on road A, then all the three sensors A1, A2 and A3 will be active. Thus, we will move to S8. If there is a moderate amount of traffic on road A, only two sensors A1 and A2 will be active and will be moving to S7. In case of slight amount of traffic on road A, only sensor A1 will be active and so will be moving to S6. Also, it is possible to move to S6 and S7 from S8 and to S6 from S7 in case the traffic is being cleared on road A. For example, if there is a huge traffic on road A, so we are in S8. After a while, the traffic starts to clear up, so we gradually move to S7 and then S6. Similarly, S10, S11, S12, S14, S15, S16 and S18, S19, S20 does the same job for road B, road C and road D respectively. Similar logics apply for these states like the ones for road A. The reason for three different states for a single road is to realize the traffic density on each road. Now let's suppose all the traffic of road A has been cleared. So our system will move to S9 from S6. So road A will be given the yellow signal now, and then it will be given red signal when it moves back to state 0. Same case applies for the other three roads as well in S13, S17 and S21. After all these states, the system will reset and move to S0 and the traffic cycle will start once again. Our traffic system is also a real-time density-based system. Suppose at one moment road A has green signal but traffic density in road C is greater than road A. So our traffic system will be able to realize this and give green signal to road C, turning road A signal yellow then red. For example, if we are in S6 state and only A1 is active and at the same time C1 and C2 both turn active, it means now we have a greater vehicle density on road C than road A. So our system will move to S9, then S0, then S1, S4, S15, and thus the green signal of road A will turn into yellow, then red, and the road C will be given green signal. This system ensures a proper management of traffic on all of the four roads. Now, what will happen if there is an emergency vehicle? For emergency vehicles, S22 will be active. After that, the system will check for the road that has the emergency vehicle. Depending on the output of the sound sensors, we will move to either S23 or S24 or S25 or S26 for presence of emergency vehicles on road A, B, C or D respectively. These states will be active as long as the emergency vehicle is present. After that, we'll move to S9, S13, S17 or S21 for road A, B, C and D respectively. Our traffic system also has a camera module to catch any traffic rule violation. Our system has a total of 4 RC1, RC2, RC3, RC4 violation detector sensors. These sensors are present in front of the stoppage line of each road. Thus, during a red signal, all of the vehicles should be behind the stoppage line and the sensor value should be low. But if any vehicle tries to violate the rule and move through, the sensor will be active and the camera module will turn on. The camera will capture the image of the vehicle and send it to Traffic Road Authority for further investigation. Lastly, there is a priority condition for a traffic system. In case of equal traffic congestion or emergency vehicle on multiple roads, the priority would be road A greater than road B greater than road C greater than road D.
Hello, I'm Mohammad Ali Kazmi, role 61, and right now I'm going to explain our Verilog code and show you some simulation results. Okay, so now we will talk about our code. So before that, we need to talk about ID, which is a 12-bit output variable, and it describes the lighting conditions of all the four roads. So among the 12 bits, the first 3 bits are for road A, the next 3 bits are for road B, the next 3 bits are for road C, and the last 3 bits are for road D. So if ID has a value like this, then it means all the roads will be red. And if ID has a value like this, then it means road A, C, and D will be red, but road B will be green, as we have a 1 in the 6th bit. Okay, so this is our Verilog code. So at first we're defining all the 27 states, and this is our main module. Here you can see our input and output variables. So at first we're initializing the inputs, and then we have 3 always blocks in our code, and the first always block occurs whenever the clock has a positive edge, and in that always block the state value is updated with the next state value. And in the next always block, it will occur whenever the state value changes, and here we are defining the ID value depending on the state. And on the next always block, it will occur whenever any of these variables or any of these sensors will change. So mainly in this always block, what will happen in each state is defined. So for example, if you're talking about state 0, in state 0, if any of the sound sensor gets an output of 1, then we will move to state 22. And if any of the density tracking sensors gets an output of 1, then we will move to state 1. And if none is the case, then we will stay at S0. And similarly, the same logics are written for all the 27 states here. And after that, we have a task in our code, and in state 1 we have to determine which road has the greatest vehicle density. So to do that, this task is needed, and this is our final code. Okay, so now let's look at some sample results. So this is a simple traffic system shown, no emergency vehicles or no camera module activation. So at first you can see that A1 is high, so road A is getting green signal here. And after this point, when clock reaches this positive edge, you can see that C1 and C2 both are active. So now road C has greater traffic. So road A is getting yellow signal, and then it is getting red signal, and road C is getting green signal. And at this point, C1 and C2 is low again. So traffic is cleared at road C. So road C gets yellow signal, then red. And at this point, road B gets green signal. As you can see, B1 is high right now. So road B gets green signal. And then road B1 is low after this point. So road B gets yellow. And after that, all of the roads get red. Okay, so this example shows what will happen if someone tries to violate the traffic rule. So at the beginning, D1 is active. So road D gets green signal, then yellow, then red. And at this point, you can see that B1 is active, and also C1 and C2 are both active. So definitely there is more vehicle density on road C. So road C gets green signal, and then it gets yellow, then red. And at this point we have still B1 is high. So road B gets green signal, then yellow, then red. At this point it gets yellow because B1 is no more activated right now. And you can see that at this point, when road C was getting green signal, then RC2 was activated. So what does that mean? That means that at this particular moment, some vehicle at road B was trying to cross the road, but the road B signal was then red. So there's a traffic rule violation, and for that, the camera module is activated for that particular period, and we are capturing the image of that particular vehicle. Okay, so in this result, we are dealing with an emergency vehicle. So at the beginning, A1 and D1 are both active, but you can see that road A gets green signal because in our priority condition, we have mentioned that road A has higher priority than road D. So road A gets green signal. After A1 switches off, it gets yellow, then red. At this point, road D gets green signal, and then yellow, then red, because at this point B1 is activated and D1 is turned off. So road B gets green signal, then yellow, then red. Now why this gets yellow? Because at this point, SS3, the sound sensor of road C, is activated. We know that B1 is still high, but we are giving more priority on the sound sensors. So at this particular point, the moment that SS3 turns on, road B gets yellow signal, then red, and then road C gets green. And it stays green as long as the sound sensor is active. So we are letting the emergency vehicle to pass. After that, road C gets yellow, then red, and after that, we still have B1 high. So road B gets green signal once again till here, then road B gets yellow, and then red. Okay, so in this example, we're mixing all of the possible things that can happen. And at the beginning, B1 and B2 and D1 are active, but road B has more traffic density, so road B gets green signal at the beginning, and then yellow, then red, red. And during this time, RC4 is activated, so someone in road D is trying to break the rule. So the camera module is turned on for that particular period. So after B1 and B2 switches off, and D1 is activated, so our road D gets green signal till here, and then road D gets yellow, then red. And at this point, you can see that A1 is high, so road A gets green signal. But at this point, the road A's green signal switches off and it turns into yellow and then red because SS2 is now activated. So road B has an emergency vehicle, so we are letting road B get the green signal till the emergency vehicle passes, then yellow, and then red. After that point, there is no emergency vehicle, so right now we can see A1 is high, so road A gets green signal once again till here, then road A gets yellow, then red. Okay, so now we're doing a live demonstration. So at the beginning, it was difficult to see the ID values in the small yellow and red parts. So we will zoom in here and check what happens here. So at the beginning, D1 and D2 are only active. So now we're still on the red state. And after that, you can see that the green road D gets green signal. And if we move forward, at this point, C1, C2, and C3, and D1, these four are active. So that means that road C has now highest vehicle density. So road D gets yellow signal, then red signal. You can match the ID values accordingly. And at this point, road C gets green signal right here. So after that, road C gets green signal till this point. At this point, C1 and C2 turns off. So that means that road C is now clear. Then after that, road C gets yellow, and then all the roads get red at that point. And during this time, you can see that RC1 is active. So that means someone in road A was violating the traffic. So camera module is turned on for that particular time. And if you move forward, at this point, you can see that A1 goes active right here. So now A1 and D1 are both active. So we are giving more priority for road A. So road A gets green signal right here. Road A gets green signal. After that, road A gets yellow, then red, because A1 is switching off right here. And at this point, only D1 is active. So road D gets green signal up here. And then at this point, SS2 is active. So that means that road B now has an emergency vehicle. So road D gets yellow signal, then red, and at this point, road B gets green signal till here when the emergency vehicle passes. After that, road B gets yellow signal and then red. So at this point, D1 is still active. So road D gets green signal once again, and this will continue further.
Hello, I am Muhammad Adnan Faisal Hussain, role 63. So today I'm going to talk about the Proteus simulation of our smart traffic light controller using Arduino. So first, if I talk about the setting we have here, we have 4 roads, and for each of these roads, we have a set of 5 sensors, and we have a traffic light, red, yellow, and green. Also, if we talk about the input and output pins of the Arduino, we have our system has 21 inputs and 13 outputs. The 21 inputs are the 20 sensors of the 4 roads and the clear pin, and our outputs are the 12 red, yellow, and green lights for each for the 4 roads, and the output of the camera, which shows whether the camera is on or off. Okay, to show whether a sensor is on or off, we are using logic states. If a logic state is 1, it shows that the sensor is on. We also use the same rule for the camera. If the output of the camera is 1, which we consider it to be on. So let's start the simulation. So initially all the roads are red because there are no vehicles in any of the roads. Suppose in the first road we have 1 vehicle. That would mean that A1 sensor would get activated. As soon as A1 is activated, we can see that this road becomes green. So soon as the car passes, this sensor will no longer read the car, and this will become 0 again. Once it becomes 0, we can see after it goes through a transition yellow phase, the signal will become red once again. Now suppose we have a car in B, and so this signal of road 2 becomes green. Now before this car can pass, suddenly the traffic in road 3 increases, and it increases a lot, so that 2 sensors are on. Now according to our smart system, because this road needs to get cleared faster to avoid a traffic gridlock, this signal in road 3 will become turned on as it has more sensors, as it has more traffic. Soon as this road clears out, we will see that now finally road 2 can get cleared. Now again, suppose we have another car in 3. So this road is going to get cleared now. Now before this road can get cleared, we have 1 car in road 2 and another one in road 1. Now after this vehicle in road 3 has cleared away, this is going to become red. But instead of going to road 2, the signal in road 1 will become green. This is because we implement a priority based system where if 2 roads have the same amount of vehicles, road 1 will get more priority than 2, 2 will get more priority than 3, and 3 will get more priority than 4. Now even though the vehicle in road 1 has not cleared yet, suppose one of the emergency sensors, the emergency sensor in road 4, gets turned on. Immediately, road 1 will become red and road 2 will become green, so that the emergency vehicle can pass. Now, once the emergency vehicle has passed, this road will again become red and road 1 can clear. Now, suppose before road 1 clears, we can see that their vehicle has been stuck in road 2 for a while. And suppose this driver gets impatient and he breaks the signal. So while this the signal in road 2 is red, if this driver breaks the signal, the RC sensor here will become 1. And once the RC sensor becomes 1, we can see the camera will get turned on and we can take a picture of the driver which is causing the infringement. In this way, uh, we can see that so basically this is how our um, smart traffic light controller works. It first it works based on the number of the amount of traffic density, and it also takes into account emergency vehicles and and takes pictures of traffic infringements which can be punished later. um, thank you.
So finally, we would like to thank our course teachers for letting us work on this project. Thank you.